Hello, hello, hello. Welcome to Cloud Native London. This is our October 2021 meetup. Brilliant to see you all here as always, whether you're joining us from YouTube or from Twitch. As always, I'm going to start with just a little bit of music, and we're going to listen to this for about 10 minutes. So feel free to just kick back, grab a drink, relax, and I will see you very shortly. Well, sounds like music just cut out. So not to worry. I think we are pretty much at 7 o'clock UK time. So let's just kick off. So once again, welcome to Cloud Native London. This is our October 2021 meetup. Cloud Native London is a strong, open, diverse developer community dedicated to the cloud native platform and technologies, usually in London, but like everything else, online at the moment. My name is Cheryl. You can find me on Twitter at oicheryl. You can find me at my blog, oicheryl.com. I've been involved in Cloud Native for a little while through the CNCF, through this meetup, and now I am at Apple as an engineering manager. Tonight, we have two fantastic speakers for you. Firstly, Rick is going to talk to us about top 5 IT challenges that you should be prepared for. And then we will go to Nicola, who's going to talk about AWS App Runner, production web applications at scale made easy for developers. And then we are going to wrap up at 8:15 UK time. First of all, here's a couple of questions that I want to ask you. So if you have a phone or a laptop or tablets close by, please grab one of those and go to this link, oicheryl.com/p, where I'm going to ask you 3 questions about yourself, and then 2 questions about how you use Cloud Native. And I'd like Rick and Nicola to turn on their videos and just chat with me as the results come in. That's oicheryl.com/p. If you miss this one, there's a slightly longer URL you can also find. This is a slightly longer URL, polev.com. And I see people have already started submitting their answers. So the first question is this your first time at Cloud Native London? And looks like, yeah, most people have been here before, so they know how to use our polling service. We've got 25% of people joining for the first time. 33%, it is jumping up a little bit. I'm always a big fan of new people coming to find Cloud Native London, and also a fan of people coming back. So either way, I'm really, really happy to have you here. And give this another couple of seconds just to let people log into Poll everywhere if they haven't. Figure this out. Said you should just see 2 answers, yes and no. That should be it. Nice. Looks like we've got 2/3 no and 1/3 yes first timers. So either way, very, very, very warm welcome to all of you. Next question, where are you now? So you should see this map and you should just be able to click on a pin and it will, drop down to where you are. So as I said before, this is Cloud Native London, but we are all over the place right now. Still good showing in the UK, but I see someone's in India, I think Portugal and Spain. I think, you can also update your location. So I'm not sure if this person just put themselves a little bit closer to where they actually are. Someone in the US, possibly that is one of our speakers who's joining us from Washington, DC, I think today. But nice. Oh yeah, I think that might be the case. So awesome. Wherever you're joining from, again, very, very good to see you. Third question for you. What is your job title? So just pick the thing that's closest to what you're doing. And your options are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, and anything else. Anything else is actually putting ahead pretty strong today. Coming up to 50%. Interesting. So if you want to put into the chat what your job title is and introduce yourself a little bit more, then feel free to do so. I think this might be the strongest showing I've ever seen for other. So it's kind of interesting. Yeah, I'd love to find out what you're doing. Usually we have a mix of, SREs, architects, and maybe a handful of others. So yeah, nice. Just give another couple of seconds just in case there's any other answers coming in. Okie, I think people will figure this out. Right, now we're going to go on to the questions that our speakers have submitted. The first one is from Rick. And the question is, what is your top hybrid cloud priority? So your options are multi-cloud environments, CI/CD, self-service IT, simplifying integrations, and cloud costs. So Rick, let me just ask you, what were you thinking when you put together this question?
Well, we see a lot of activity across all these. Generally, this is led by self-service IT, but we've seen a lot of interest around CI/CD recently, and as you can see in the results here. So those kind of that's interesting. Up there, CI/CD taking the lead. I think I'm pumping it up a little bit. How about cloud cost? Anybody? So yeah, that's not entirely surprising.
I'm CICD is definitely putting ahead, but actually I was wondering if you could kind of elaborate a little bit more on some of these answers. Like, how do you see hybrid interacting with each of these?
Well, as our IT estate spreads across on-prem into hybrid cloud or into the public cloud, how does how do first off, how do we incorporate these with a multi-cloud environment? It's the firewall is no longer a border firewall on your data center. It's sort of everybody sitting in a data center, so it provides a lot of unique challenges around managing that process. In terms of CI/CD, how do we offload the most sensitive tasks into our on-prem and maybe our less sensitive, more processing intensive tasks off the public cloud across the same pipeline? Self-service IT is always a high priority in any organization. It has been for years, especially with the emergence of cloud. How do we make it easy to go for your mainstream users to reach out and provision their own resources, manage their own resources without having to learn every cloud and every nuance of those clouds. And then, of course, with any sort of automation comes integrations. How do we simplify those integrations? And then, of course, cloud cost, which we see a lot of interest in these days, where, okay, we've moved to the cloud, we have a hybrid cloud strategy. What's it costing us? What are we spending on it?
Interesting. Yeah, I mean, I definitely see every organization talking about cloud costs and having to worry about that. But it definitely seems like CI/CD is the main priority for people. So it's good to hear or interesting to hear that it lines up with
Yep,
what you expected.
absolutely. And it lines up with the titles I saw. So I saw a lot of DevOps folks on here, so not entirely surprising there.
Cool. Thank you so much, Rick. Let's go to our other question. And Nicola, so this question is, what do you use to deploy a new application? Your options are CLI, a native CI/CD pipeline, a custom CI/CD pipeline, some kind of semi-automated or manual approach, or other. So again, Nicola, what were you thinking about when you wrote this question?
Yeah, basically, I'm trying to also to get the feeling a little bit from the audience on the way how the application are deployed. This also will help me introduce the topic as well. So it was like a little bit of also kind of tasting the audience right there. Not surprised to see the use of custom CI/CD pipeline also that start to kind of be more prominent there. And I also believe the CI/CD pipelines basically represents reliability, resilience, and innovation. So it's for sure a very important part into the application deployment.
What did you mean by the difference between native and custom?
Yeah, I was kind of referring to the fact that every cloud providers provide, again, a kind of a native cloud CI/CD pipeline. With custom, I was more referring to something like, I don't know, Jenkins or something that can be even customized or which is not cloud, maybe native or available from some cloud providers.
Ah, got it. Okay, interesting. We just saw this drop down to 0, so maybe somebody changed their mind after hearing that explanation. I mean, I don't know what would fall into other, in your opinion.
Yeah, probably anything else that I wasn't covering in those 4 categories. So maybe third-party tools or other things that we didn't factor in these 4 categories. But yeah, probably we already covered most of the tools in those 4 categories.
Yeah, definitely seems like the custom CI/CD pipelines and some semi-automated or manual approach are the clear winners here. Interesting that 15% of people still say they use just the CLI. Cool. All right, thank you very much. Thank you for taking part in this poll as well and allowing me to get to know you a little bit. I think that is the end of our questions for this evening. Fantastic. Okay, I want to say thank you to our sponsors who keep this running. So we've got a couple of people on tonight to introduce themselves. David, would you like to go first?
I'd be more than happy to. Hi there. Good evening, everybody. Yes, Dave McLean, part of the Prisma Cloud team, or Prisma Cloud and Bridge Crew team at Palo Alto Networks. And we help customers stay safe. And so naturally, that's helping them implement security across their cloud, their workloads, and their lifecycle. So common themes at the moment are principally around helping them with their infrastructure as code and reducing the number of misconfigurations and alerts in runtime, and also looking for vulnerabilities in dependencies as well, container image packages or any packages within an application manifest file. So yeah, that's what we do every day, and what I get to help customers with every day. And yeah, thanks for letting me do a short intro today.
Brilliant, thank you so much. Let me hand over to Zan. Zan, would you like to introduce Circle CI?
I definitely would. Thank you, Cheryl. Hi, everyone. On behalf of Circle CI, I'm Zan. I'm a developer advocate here, and we're the world's leading CI/CD platform. So probably very relevant for today's topic. So whatever you're trying to build, whatever you're trying to deploy, test, or automate in how any other way, we help teams all over the world do just that. So yeah, whatever you're working on, Kubernetes, serverless, mobile apps, static websites, yeah, that's what we do, Circle CI. Do check us out, circleci.com, or yeah, at Circle CI on Twitter.
Brilliant, thank you so much. I believe that NetApp and Humio could not send representatives this evening, but again, I want to just say thank you to all of you, because that's what keeps this meetup running and has kept this meetup running throughout the whole course of this pandemic. I am looking to go back to live events pretty soon. So if you happen to know of any offices around central London that are opening up to live events again, please do let me know. I'd love to come and start meeting people in real life again. If you want to come and speak or sponsor Cloud Native London as well, you can go to cloudnativelund.com, and we have some speaking slots available from February of next year. You can also find out how to sponsor or how to promote your own event. I think that is it for my introduction. I just have one more thing that I want to tell you about, and that is that this is my last Cloud Native London for a little while, for a couple of months. And the reason for that is that I am pregnant. So I'm about to go on maternity leave, and I think I'm going to be a little bit too busy, maybe, to host this meetup for a little bit. But not to worry, we are still running. So we have, Sam says that, congratulations. Oh, Nicola, thank you. We're still going to keep this meetup running, so no worries. We've got an alternative host lined up who's going to take over for me for a couple of months. But I just want to say thank you again, and like, I'll be back in not too long, I promise. Thank you for the congratulations. So nice. Okay, that is it from me for the moment. So now I would love for Rick to come on and share his screen, and I'll just hand over the stage to Rick.
Great, thank you very much. Let me just get my screen share going here, and we're up and going. Great. So, thanks everybody for joining us today. Thank you, Cheryl, for that great introduction, and everybody else and our sponsors for making this a reality. Really looking forward to getting back in live in person, and really looking forward to getting back to London. So I'm based out of the States. I'm in Washington D.C. My background is I've been CloudBolt software for almost 9 years now. My background is primarily in IT automation, going back to the days of Loud Cloud and Opsware back in the mid-aughts when we were really automating bare metal provisioning and so forth, which was always have some great stories around that for another time. But eventually moving into virtualization, eventually cloud, and eventually led me to CloudBolt software, where we sort of took that cloud model and applied it to the on-prem data center and public cloud to build a hybrid cloud platform. So with that, today I want to talk about the top 5 challenges every hybrid cloud strategy must address. These are things that come up, we see over and over again with our customers, it's kind of at some point you're going to have to cross the bridge on these issues. And we already did an introduction. Great. So today's cloud challenges. I mean, go do cloud problems, or go search for cloud problems on Google. Top 10 are security data, insufficiency of resources. You see there on the slide there, complete governance and compliance, cloud cost management, multi-cloud environments compliance, cloud migration, vendor lock-in, the list goes on and on. These all kind of translate to the common problems that we hear at CloudBolt. Shadow IT. We've been hearing about shadow IT and VM sprawl for a long time now. 33% of all attacks are due to shadow IT. Things that are sitting out there that have been built, provisioned, and sort of lost. So it's almost worse than the old story of the server under the desk that you don't go near and you don't touch. These you don't even see. They're just a line in a table of resources. So they kind of sit there and just cost you money and eventually open up attack surface. An ever increasing number of tools. Look, enterprise tools, software configuration management systems, those types of things, they come, but they never really go. They're always out there, and they tend to stick around and have to be dealt with for a long term. Enterprises will have 5 more tools from new markets that don't even exist today. Difficult cloud migration. More than half of organizations say that poor integrations take a $500,000 toll on their business every year. So just integrating these systems that whether it be applications, whether it be the IT back office systems, really creates a large drag on those processes and cloud migration in general. Idle public cloud spend. This is the stuff that's out in the cloud that you're paying for and probably don't realize it. So somewhat related to shadow IT, but also with the idea that it goes beyond VMs. It could be load balancers sitting there in the cloud. It could be disconnected or disassociated volumes sitting out there. All these elements, most of these elements, all incur a cost. How do you track them and how do you find them? So that's a big challenge that we see a lot of. Lack of expertise. I mean, more often than not, user configurations, the sort of the biggest issue that leads to security breaches and problems. How do you educate those users on what they should be doing, where they should be provisioning, which VPCs they should be using, which security groups, all that backing information. Lack of automation. You'd be surprised how many prospects we see that haven't automated any of IT yet, even these days. Custom coding. We see a lot of custom coded solutions that are built around, or automation solutions that are built around custom coding. We saw we did the survey about CI/CD, about whether you use a native CI/CD or a custom CI/CD. Well, the custom one's going to have custom coding, and a lot of times those become very difficult to manage over time, because these organizations that we deal with, which are largely Fortune Global 5,000, 1,000 type companies, they'll have a automation initiative going across the enterprise, where all these teams are automating to their back office IT systems and clouds and so forth. Well, what happens when something needs to change in that back office system, whether it be a upgrade, whether it be a security remediation that forces an upgrade, a change of products? Well, then you have to go to all those teams that have integrated with that tool and tell them, hey, go back and get on your roadmap, get in your backlog the tasks of updating your API calls to this new tool. And it's a very, very difficult prospect and a very costly prospect. And of course, compliance costs. We see this over and over again. I've heard one person describe it as a raging dumpster fire, compliance in the cloud. So, misconfigured cloud workloads led to $1 billion of lost records a few years ago. So these are all sort of the general top cloud challenges, but I'm going to drill into 5 and see if we can build a conversation off that. So the first one is more clouds equals more complexity. Okay, 78% of IT leaders that we talk to have limited insight into who's provisioning what, where to optimize costs, and how to remediate security issues within these hybrid clouds. What this means is because there's so many tools, so many places, and I also alluded to earlier, everybody's in the data center. If you're in cloud, everybody's sitting in the data center. You really don't have any unified visibility into this hybrid cloud infrastructure. So that's a big problem that we see over and over again with our customers. It's just general visibility. What's out there? It could be customers using cloud management systems like our own product. Okay, that helps a lot in controlling visibility. But the reason why it does help is it has this ability to identify brownfield resources that were provisioned outside of CloudBolt in the actual native clouds, bring those and assimilate those into the product. So you still have to have that idea of, whatever tool you're using, it still has to go out and find brownfield resources that are out there, or out of band resources, I like to call them, that may have gone around the controls in place. Next is controlling cloud spend and waste. Okay, 40% of the respondents to IDG's Cloud Computing Survey in 2020 cited the need to control cloud costs as an obstacle to their continued use of cloud. Look, like I have many anecdotes of customers that thought, hey, we're moving to cloud, it's going to be cheaper, and what they found is, their operational costs were essentially parallel to their revenue. The more they had a hard time getting that operational cost down. That's a lot of times what will happen if you just take your data center and put it in the cloud. You have to, in a lot of ways, leverage cloud native technologies and so forth, and economies of scale that offered there to sort of break those two lines apart, so your operational costs can split from your actual revenue that you're seeing. So we see that a lot where customers jumped into the cloud maybe early on and found out this is an expensive operation, and we need ways to either reduce that operational cost and bring that down in line in the public cloud. So the third of the big challenges is ensuring CI/CD infrastructure reliability. I think this will resonate pretty well with this crowd here. Look, when it comes to CI/CD, a reliable infrastructure for DevOps pipelines is important beyond just the active development. Organizations need those pipelines to work, to be able to push that code out to their customers, to push back on the competition. The The last thing a developer wants, and this, I'm putting my developer hat on from earlier in my career, is to go to release software and hit a CI/CD problem. Then they have to run to you folks, the DevOps folks, and say, hey, I'm trying to push my code, and there's this problem, there's a strange error. Can you help me? Like that's only 11% of the companies that we surveyed believe that their CI/CD infrastructure is very reliable, and that's a big challenge. It's a really big challenge. That there's also the element of if I'm working with a CI/CD pipeline, if I'm looking at the beginning to the end, I'm a developer. I push my code in. It starts working through the security tests. It does some provisioning tests or whatever it has to do to actually deliver this to production. And something breaks. Okay, well, a lot of security pipelines don't have the concept of okay, well, just pick up where you left off and try it again. You have to go back to the start and run it through again, through all the tests again. And that's by the very nature of what CI/CD is. And everything that happens up to that break is a waste. Whether it's provisioning resources, whether it's time, whether it's just it's toil, it's a waste. So anytime you can remove those repeated steps or having to replay those steps because of some problem is a big value to any CI/CD pipeline strategy. The next big challenge that we see is simplifying self-service IT. Like our customers like to tell them, like there's 60 to 80% of your users that request the same thing over and over again, many times. I call them the mainstream user base. That mainstream user base, with the developers, whether they're semi-developers, citizen developers, what have you, they want access to resources to be able to test their ideas. It may be a scientific organization that wants to go out and they have a lot of scientists that are technical, but not IT people. Okay, so they know they need a server and want to be able to use a server and test their scientific runs and experiments, but they don't have the background of cloud. They don't know what a security group is. They don't know how to subnet a VPC's network. So how do you get them into the cloud and get them easy access, especially across a hybrid cloud, which would consist of technologies that are very different? A vCenter is a very different technology than, say, an AWS console. So how do you bridge those two is a big challenge for hybrid cloud. And also to that point, as you focus in on that 60-80%, you're always going to have that 10-20% of those power users that are going to have direct access to the console, and that's okay. That's totally fine. Like, give them access to the most minute details they need in that cloud. But again, if you focus on capturing that 60-80%, you're really going to make a big difference in your organization, a big positive impact. And that's the thing to focus on. Don't try to focus on grabbing 100% of everybody out of the AWS console. We've seen very few demonstrable successes based on that sort of thinking. Okay. And the next one is streamlining integrations for a multi-tool world. So I mentioned it earlier. Like, tools come, they never go. They're going to be out there forever, whether it be Terraform. And hey, I love Terraform as much as everybody else. I really do. There's going to be something else behind Terraform. I can almost guarantee it. And there'll be something behind that. So, but Terraform will be around for many years to come. Okay, so you really have to sort of architect your hybrid cloud strategy, knowing that these technologies are to come and eventually go, and make sure you have provisions in place to. Sorry about the dogs barking in the background. But have the provisions in place to accommodate those new technologies as they come, and continue to embrace the old technologies, because we can't keep rewriting all of our automations and integrations every 2 years. It's just not. It's not a viable process going forward with automation. IT leaders are unanimous. 99% said when it comes to the essential role that streamlined integration plays in accelerating automation. So integration is not going anywhere, especially in this API-driven world that we live in now. 62% want integrations that don't require deep domain knowledge of different tools and technologies, and that's key. Anytime you can abstract away, the the intimate details of talking to an IPAM from those users that are doing that automation, it's a huge win. The intimate details of what it takes to provision a resource in AWS. And in some cases, the details of what it takes to run Terraform. We see a lot of cases where we have a core group of automators that are using Terraform, love Terraform, but their mainstream user base does not know Terraform. So you have to think about them. You have to figure out, like, how do I get them into the system easily? And if teaching them Terraform, installing on their workstation, and training them up on it is part of that plan, you're probably going to see some headwinds there. So I'm just checking my time. I'm way fast, but some key takeaways from this. One, high complexity, high cognitive loads. Visibility is king. So the more complex the cloud environment is, the more cognitive load that you're going to place on your users to consume resources in that cloud. Meaning, multiple clouds, multiple consoles. I have to train my users, which VPCs to use, which virtual networks, how to work with those virtual networks, how all that works, which security groups to use, what is a security group, how ports work. It's almost an unending hole of operational knowledge that you have to transfer to these users. So, as part of that, visibility is king across those complex environments, and really the cognitive load comes down to a lot of self-service stuff. Number two, cloud costs. You can't manage what you can't automate. So, being able to automate, whether it be reports, whether it be generated visualizations of your individual workloads, whatever it is, you really got to be able to automate that. And not only that, you also have to try to get out of this model of, well, FinOps runs their report and they walk down the hall knocking on doors of those of you that have wasteful resources in the cloud. Because A, we're not all in the same place anymore, and B, it just doesn't scale again. So the key there is to empower those everybody, all the developers, all the users of these systems with information they can look at and decide upon to take action upon their own workloads. So look, if something's sitting there idle and there's a potential to save $50 a month, reach out to that developer, ask them, in an automated fashion, do you want to turn this resource down? It can save $50 a month. Great opportunity for things like chat bots and so forth to reach out and proactively contact that owner of that workload and do it so in an automated way. CI/CD, infrastructure reliability. Who's testing the testers, right? So you have these tools, you have the CI/CD pipeline. I almost like that. It's kind of like an assembly line in an automotive plant. Highly robotic. All these things are happening, very automated. But how do I know the robots are working right? Like, how do I know they have the proper software in there, they're configured properly, and everything else? Be thinking about what does that look like? What do those tests look like to make sure that CI/CD pipeline is running optimally on an ongoing basis? Number four, self-service IT and everything as a service. Consumable is a lot of times better than configurable. I know it sounds sort of crazy, but it's true. Focusing in on that mainstream user base, they're often more I'd say concerned about getting access to the resource they need than having the ultimate ability to configure every aspect of that resource. So give them what they want when they want it, and they can get to work and be agile. And then 5, integrations. First class citizen and organization ownership over integrations. No more like, hey, went down the hall and talked to the IPAM person, and they're going to create an API account for me, and I'm going to connect to it, and no one will be the wiser. Like, other than that person, like that can't continue for a variety of reasons, whether it be large scale automation operations that are tie each of those automation projects to that back end technology. Or if it's just a matter of scale, you need to have some level of abstraction between the end users that are automating, whether it be via Terraform, via scripts, via Ansible, and those the back end technologies that they're talking to. And that's what I have for today. So short, sweet. I'm probably speaking a little fast. I'm a little bit over time or under time here. So at this time, I'll open it up to the floor for any questions or comments.
Fantastic. Thank you so much, Rick. Actually, I found this pretty interesting. Do you mind if I take over sharing the screen for a second?
Sure.
And I'm just going to put up a place for people to submit questions. So this is a bit like Reddit. This is the same link as we were using before, but you can just type in questions here, and then you can sort of thumbs up and thumbs down Reddit style to vote for the questions that you want to ask Rick. So yeah, no, I liked your kind of 5 takeaways at the end. I mean, it feels very, I'm sure for a lot of organizations and customers that you're talking to, it feels like the promised land in a way, being able to automate everything, and there's a lot of hurdles, right?
There really is, and I cannot convey how often I hear that story of, we had this big automation effort, everybody automated with this tool, now that tool is essentially frozen. We can't change it, we can't adjust it, we can't even upgrade it, because if we do, we then have to get on the backlogs of all the teams that are automated with it, and then ask them to synchronize with us. So you have to synchronize all those teams when you get in that situation, if you're directly bound there. So a level of abstraction between the two is almost a must now.
Do you think that there's how would you suggest that teams think about this to avoid getting in that situation?
Yeah, I would say they think about it in terms of there has to be a common, whether you wrap a existing API in your own API, there has to be some common contract that doesn't change despite whatever happens in that product behind the scenes. So what happens is, okay, so we're going to upgrade this system. The external API, all your tools will stay the same. They'll all still make the same calls and everything, but it's up to our team who owns this tool to adapt that indirection layer to talk to the new tool. So it's much easier to coordinate that process than ask everybody to do it on sort of a point-to-point basis.
Right, because it's a little bit of a craft, right? It's a little bit of an art to know how much to expose. And if you expose a little bit too much, then you tie people to the internal operations again, I would have thought.
And that's exactly right. And while I had one customer tell me, like, well, it's web-based API, so it's already open. That's a ridiculous comment. I'm like, have you surely you don't know what you're saying. If you've ever used any API, you know that give me 5 tools and I'll give you 5 very different web APIs. They all have their own little quirks, whether it be parameter filters or credentialing or whatever else. They all have their own quirks. There is no sort of de facto standard. Any sort of indirection there you can provide is usually very helpful.
Do you see any other common challenges with the customers that you talk to?
I think in the self-service side, I think the biggest challenge there, and I already covered this one, but like, don't try to automate don't try to self-service enable the entire organization. It's never going to work. Start with a group, build little islands of goodness, and build from those islands of goodness. You start connecting those islands and go from there. Don't try to bite the whole organization off. It's very difficult to get that working. Shoot for the 60%, 80% user base, and prove that out before you start trying to go after 100.
I see we have a question. Where can we see a demonstration of the product at CloudBolt?
Yeah, I mean, you can contact me at cloudbolt.io. We can get something set up and give you a full demo of everything CloudBolt offers, whether it be CMP, cloud security and cost management, or our integration platform.
Cool, thank you. Oh, perfect. There was something that you just mentioned that I was going to ask you about, and it distracted me from it. I was asking you about other common challenges.
And I was talking about user base. Go to the 60-80% user base and
yeah. So how would you target that, your initial group to start with? Like, what kinds of workloads do you think work particularly well, or is it up to the teams?
Yeah, you can follow there's a lot of stats online about the most popular services offered by these public clouds. Overwhelmingly, it's EC2. EC2 for AWS is overwhelming. Most people still want to work with VMs, okay? And from there, you'll probably get an S3, and after that, maybe RDS, and then you start seeing EKS, and it's the same for every cloud. I mean, you see the same patterns. We're still very much a VM-centric world, despite the fact that a lot of organizations are trying to move towards Kubernetes and the like with containers. So that typically seems to be the lowest hanging fruit. And then from there, you can start expanding into other services. And what's more is you can also build your own services internally. Like, don't underestimate the value. I mean, here's a big challenge. Like we want to have a corporate database service. Corporate wide, we've adopted Postgres. We don't support MySQL. So I don't want users going to RDS and spinning up MySQL instances, or I don't want them going to Azure and spinning up MySQL instances. So I can create my own services internally, similar to like an AWS service, only it always results in a Postgres database. So being able to provide that sort of capability on a self-service basis is invaluable.
It looks like we've got another question. What cloud providers do you support?
All the big three, of course: Google, AWS, GCP, and we have like IBM Cloud, Oracle. Internally, we support for on-prem vCenter, Nutanix, Acropolis, OpenStack. I think what else? Alibaba. So we have quite a few cloud providers we support today.
Cool, fantastic. I think doesn't feel like we're going to get too many more questions. So are you happy to wrap up there, Rick? Is there anything else that you wanted to?
No, that's it. I just want to say thank you.
Thoughts?
Please drop me an email if you want to take a look at the demo, and go from there.
Fabulous. Thank you so much, Rick. Really appreciate you sharing your experience and your wisdom with us.
Thanks. And I forgot to turn my video on. So hello, everybody. Thank you very much. Have a good evening.
Thank you so much, Rick. All right. I'm going to hand over now to our second speaker. Nicola, do you want to share your screen and take over?
Sure. Here we go. You should be able to see my screen now. And again, hi everyone. My name is Nicola Pietroluongo, and I'm an AWS Senior Solutions Architect. So today I'm gonna introduce AWS App Runner, a fully managed service to quickly deploy containerized web application and APIs with no prior infrastructure experience required. So we're going to see what is App Runner and where is best suited. Why we built App Runner. And we will walk through the history and the evolution of compute services on AWS. Then we'll see how to use and configure App Runner with a little demo. And finally, we will have some discussion about additional features, and we will see some takeaways. So let's see, what is App Runner? App Runner is a new AWS service launched this year that provides a highly abstracted and simplified experience for running web applications and API servers. We'll talk about what things are abstracted away by App Runner in a few minutes here. But before, let's understand a little bit more about the type of applications that are best suited to run on App Runner. As you mentioned, App Runner is suited for web applications and front-end or back-end API servers, basically anything that serve HTTP-based requests. The application must be written as a longer-running server that can service many requests during its lifetime, even simultaneously. So it's not like a Lambda function where one invocation only handles a single request and exits. The The application must be also stateless, so request processing should not depend on any local state on disk. You can choose to store state in other external database and data stores. And there should be little to no background processing. And by background processing, I mean any processing that happens offline outside the context of a request. Simply because App Runner heavily throttles containers CPUs when requests are not actively being processed. So in order to understand why we built App Runner, let's look at the typical application architecture in the cloud. So you start with a server, a virtual machine. Inside the virtual machine, you install a guest operating system. Then you install the language runtime of your choice, and then your application runs on top of it. You are probably running multiple copies of this stack for scale and redundancy, which means you have to front it with a load balancer. You also put an auto-scaling group around it, so your application scales in and out as traffic demand changes. And finally, you probably have some sort of CI/CD pipeline to push updates to this application. So as you can imagine, when you run application into the cloud, you and the cloud provider needs to manage multiple elements. This paradigm is called the shared responsibility model. There is a shared responsibility between you, the customer, and in this case, AWS, around the general operational stability and security. So depending on the cloud service that you use, this responsibility looks different. Let's see some examples. So AWS released in 2006 Amazon Elastic Compute Cloud, or EC2, the original first compute service that provides compute capacity in the cloud. With EC2, AWS will take responsibility of the physical servers running in data centers and also the virtualization technology that runs on them. You, the customer, can simply make API call and spin up virtual machine in the cloud, which we call EC2 instances. And as the customer, you are responsible for maintaining all the software that runs within the EC2 instances, including the operating system and the language runtime. You're also responsible for hooking up the load balancer, the auto-scaling group, and the CI/CD pipeline around your EC2 instances. And finally, looking at the pricing perspective, you pay for your provision resources, meaning you pay for the EC2 instances and the load balancer, irrespective of whether your application is actually receiving any requests and doing any work. Now, AWS realized that stitching all these individual components together around your EC2 instances can be a complex job. So in 2011, AWS released Elastic Beanstalk, which provides a single pane of glass to manage and orchestrate the entire environment around your EC2 instances. All of these resources still run in the customer account, and you have full access to them. So we'll still rely on the customer, operate it responsibly. From a pricing perspective, it's no different from EC2. You pay for the provisional load balancer and the EC2 instances, irrespective of actual work done. Then containers became popular. And you can see here how, you can see an example of running containers on EC2 instances. You are responsible to configure the operating system, the orchestration agent, and so on. So ECS, Elastic Container Service, came into play, moving the responsibility of running the container orchestrator to AWS. All the rest is still in the customer's domain. In 2017, AWS Fargate, a serverless pay-as-you-go compute engine for your containerized application, changed the responsibility model. With Fargate, the customer runs container without managing the infrastructure. From a cost perspective, the customer pays for the resources at container level. Finally, we can see how App Runner is changing the responsibility model. Now, not only you won't need to manage the language runtime, but also you don't need to worry about the load balancer, the auto-scaling, and the CI/CD pipeline. In terms of cost, you pay only during request processing. Let's see how App Runner works in a little bit more details. So you can deploy your containerized application in two ways. You can create a connection between your Git repository and App Runner. You can also define as a source a container image stored in Amazon Elastic Container Registry. You can trigger the deployment manually or automatically. The very first time, you need to create the App Runner service and configure the amount of CPU and memory needed. When the deployment is complete, App Runner exposes a secure URL you can access to consume your web application. So for this talk, I've already deployed an application using App Runner. And I'm going to show you how I basically created the service using the AWS console. This is how the AWS console might look like the first time you open the AWS App Runner service. So you can search for App Runner in the search bar or use the link you see below. When you press on Create an App Runner service, you should see something like this. Here you can define your source. In my example, I'm using a source code repository, and within the same dashboard, you can easily link your GitHub repository to App Runner. Then you can define the repository and the branch App Runner needs to monitor. In this case, my repository name is App Runner Demo, and the branch is main. Further down, we'll find the deployment settings. We have a manual and automatic deployment, as I mentioned before. As you can see, the automatic deployment allows you to deploy at every push request. In the second step, you can choose the runtime environment. At the moment, App Runner supports Python 3 and Node.js 12. If you have different requirements, you can use container image as a source instead. After you select the runtime, you can configure the build command and start command and the port in which the service is listening to. I'm going to show you in a minute my repository and my kind of Node.js application that I've created for this demo. But you can see now, again, the npm install command under the build command and the node index.js statement under the start command. When you press next, you arrive at the step number 3, which allows you to configure the service. You can design the amount of CPU and memory to allocate. App Runner supports 1 or 2 virtual CPUs and the 2, 3, or 4 gigabyte of memory. If you scroll down, you can customize things like auto-scaling, health checks, and security settings as a role that the service should use if communicates with other services. Otherwise, you can just keep the default settings, and that's it. App Runner will configure the resources and create a domain. And you can see here my repository at the right side and the domain that App Runner provided for me on the left side of the screen. You can see from the dashboard as well an event log with the status of the deployment. So as I mentioned, I've already created an App Runner service. Now I've linked a GitHub repository. I'm going to attempt a live demo here. As you can see on the left side, there is a browser session. On the right side, there is my terminal. So this is the GitHub repository that I've linked with the App Runner service. So we saw before how App Runner creates for us a secure URL to consume the application. This is the URL that created for me, and this is just a simple Hello World application. So on the GitHub repository, you can see 2 files. So to recap, it's just a simple Hello World application in Node.js using the Express Web Framework. You can see here some statements. And you can see, hopefully, the Hello World statement. So quickly, I can show you the current status of my App Runner service just using the command line. Of course, the status is also available in things and places like the AWS dashboard as well. So my service name is Demo App, and the status is running. As we saw, I can just refresh this page, and my application can respond to requests. Now, again, as I said, let's see what happened when I change this code. For simplicity, I'm going to change the code just into the browser. And I'm going to change Hello World into Hello Beautiful word. I'm going to commit the changes. But of course, you can commit the changes using your terminal or any other tool. I'm going to rerun the command that checks the status of my service. And as you can see, very quickly, App Runner was able to recognize the changes and change the status of the service from running in operation in progress. So let's recap quickly what we have seen so far. I've already created the service, the App Runner service. As I mentioned, you can link a GitHub repository or a container image repository hosted in Elastic Container Registry. App Runner will start to monitor your changes, and then as soon as some change appears, App Runner will pull the source code. It runs the build command, in my case was npm install, and then starts the application. In my case, the starting command was node index.js, and then deploys the service. I'm going to just show you for also completeness the other file that I've got here, the package.json, and as you might imagine, the only dependencies that I've got is the Express web framework. Gonna just continue in my presentation, and I'm gonna come back to this page in just a few seconds, just to again complete a little bit what happened behind the scenes when App Runner deploys something. So let's talk a little bit about features and also covering the deployment process. This is not an extensive list, what I'm going to present. You can find, of course, more information in the AWS documentation. So in terms of networking, we already saw that App Runner basically creates a service URL in an internet-facing endpoint. The egress, in terms of outbound communication, the application instance have outbound access to the internet. So you don't need to set up a VPC, a NAT gateway, and so on. Also, what about the storage? Each application instance has 3 GB of disk space, and this includes spaces consumed by the container image. So, for instance, if I have a container image that is 1 GB, I'm gonna have 2 GB left. So the storage also is ephemeral. In terms of deployment features, we saw the auto deploy using GitHub code. So committing the code. And I mentioned also the auto deploy if you use an ECR image. So if you push a new image into ECR. Of course, there is also the manual deployment, and you can trigger manual deployment calling the start deployment API. How the deployment works, you can see that App Runner is using a blue-green strategy. So there is no downtime between deployment. Also, App Runner, when pulls the code, build and then spin up the service, basically run an health check against the service. So in case of a failure, automatically roll back what it has done. So just because I completed how the deployment works, let's see what basically, let's go back a little bit to the application. I can rerun my command line tool to see if the status has changed. And as you can see, the status has changed from operation in progress to running. If I refresh my application here, the application, now the text of the application has changed as expected. Hello, beautiful world. So let's go back to a few other basically other features that App Runner provides. And in terms of logs delivering, the logs is delivered to AWS CloudWatch. There are, of course, 3 types of logs. Deployment logs, which is the output of the building stage. The application logs, so the logs emitted by your web application. And the event log of lifecycle operation executed by App Runner during service creation and deployment. We saw some events earlier before. What about the metrics? Which type of metrics are delivered to AWS CloudWatch? There are request metrics, so request count, latency, and HTTP error codes. and also number of application instances actively processing requests. We mentioned events before, and we have the ability to use service lifecycle events as service and deployment status changes. So you can deliver those events to Amazon Event Bridge. They can be used to initiate rule-based automated action in targets like AWS Lambda, Amazon ECS, Amazon SNS, and so on. Finally, we have also API, all the API actions as the integration and interaction that you might have using the App Runner Service API are logged to AWS CloudTrail for auditing. Let me just mention some final additional features. So what about custom domain names? Of course, it's possible to associate custom domain names with your service, and App Runner will create and manage a certificate behind the scenes. In terms of data encryption, source code and images pulled by App Runner are encrypted at rest using AWS managed key. That's the default settings, or you can also use your own provided keys. And the last feature that I'd like to mention is a pause resume service. So basically, you can take the service and you can temporarily disable the service using the pause resume feature. While paused, App Runner reduces the instances behind the service to 0. And this leads me basically to the final takeaways of this presentation. App Runner offers a simplified experience for running HTTP request reply services. Multiple aspects of the infrastructure, as load balancing, auto-scaling, CI/CD, and more, are abstracted away and managed behind the scenes. Customers pay by use rather than provisioned resources. Feel free to check out the public roadmap in the link below and get started with your application. Thank you.
Fantastic. Thank you so much, Nicola. That was a really, really good overview. Nice little demo as well. I'm going to take over sharing the screen again, once again, so yes, I can please. Just put up the questions, and let's see if anyone has any questions about App Runner. So once again, you can go to this link, polev.com/Cheryl278, or the one that I gave you before, or cheryl.com/p, and then just type in any questions that you have. So App Runner has been around for a little while, right? Nicola, or is it?
2021 has been released in 2021, so it's let's say relatively a new service.
Okay.
And as I mentioned, is kind of service that make it easy to run a web application, including API services, backend, web services, and website. It's also, let's say, pretty flexible in terms of implementation of a microservice architecture, can also help in that way as well.
Mm.
The main takeaway, as I mentioned before, is there is no infrastructure or container orchestration required. So I can just deploy my code, and the code will be bundled in a container, or if I already have a container, I can push the container into ECR, and so also trigger an automated deployment.
Mm. Do you see it sort of taking off and getting a lot of adoption?
We have customers that are using App Runner currently, and again, simply because it simplifies the way how the application is deployed. Again, taking away all the management of the things that I mentioned before is kind of something that companies are taking in consideration.
Mm. Is it something that like requires a lot of migration from, just in your opinion? What do you think?
Well, probably it doesn't, because sorry, it does not, because since it supports containers, if I have also something in ECS or EKS, I can simply push my container into App Runner and I'm ready to go. In terms of code, if my code is in GitHub, in this case, since App Runner is supporting GitHub, I can just hook up my code automatically within the dashboard, the AWS dashboard. So I don't need to go back and forth or doing some strange manual link here and there.
Definitely the pay by use is it's very nice for a lot of companies, I think. That's
another benefit. Yes, of course, it's another benefit.
Yeah. I think, as you said before with Rick, cloud costs are a concern for a lot of different companies. So I think anything that makes that more transparent and easier to understand is good.
It is, yeah, of course, transparent. Also, there is this scalability with traffic. So as the demand grows or shrink, the auto scaling kicks in. And moreover, probably one of the points that I mentioned is that it's fully managed. So you benefit from security and operational best practices from AWS.
Cool. I think doesn't feel like we're going to get any questions for the minute. But I guess if people want to reach out to you, they can reach out to you on Twitter.
That's right. I'm going to also join then the Slack channel as well.
Oh, okay. Here's a question. Can we use App Runner for Laravel? I don't know what Laravel is.
PHP framework. Yeah.
Okay.
And Vue.js, Next.js. So yes, because as I mentioned before, I just show two options, which were source code. So when I go and I choose the source code, I have only two runtime available, which were Python and Node.js. But if I use a container, I can basically bundle everything I want because it's bundled in a container. So if I bundle Laravel or Vue.js or other type of framework, Next and so on, I can bundle pretty much everything.
Cool. Yeah, so I know I just said, if people want to get in touch with you, what's the best way?
Yeah, please reach out on Twitter, but I'm gonna also join the channel now to see if there are more inquiries.
Brilliant. Okay, in that case, I think we can wrap up just a few minutes early this evening. Oh, okay, as I keep saying that, people keep asking. So here you go. What's the advantage what are the advantages if I use App Runner instead of RDS and EC2?
So the main advantage, as I was mentioning before, is that basically make it easy and cost effective to run your application at scale with high availability without managing almost all things like the load balancer, the auto scaling, the CI/CD pipeline, and things like that. So you can build and run a web application in just a few clicks. That's the main advantage. And RDS is different things because you can link App Runner with RDS. So the difference would be between App Runner and manage yourself an EC2 instance.
Next question, is App Runner cross-functional with other ISA tools like Terraform and Pulumi?
So we are going to support also App Runner as well. Probably has been already integrated or is about to be integrated in Terraform. Anyway, AWS provides something called the Cloud Control API, which is a uniform API to access AWS and third-party services as well. So we have companies like Terraform that are using this Cloud Control API to put an interface against the AWS services. So the short answer is going to be possible to use Terraform as well, or possibly any other tool that integrates with the AWS APIs.
Okay, I'll give it one more minute just to see if any other questions come in. Yes, I guess I didn't even think about the integrations because I just assumed App Runner would work with all the other AWS services.
That's correct. all the AWS services are interconnected, so it's easy to connect different services between each other. I mean, just to give another little bit of background, as you might imagine, the kind of the technology behind App Runner is similar. Actually, it's based on Fargate, AWS Fargate.
All right, excellent. I'm going to call it there, and I'm going to say thank you.
And thanks, everyone.
Yeah, and thank you to Rick and to Nicola, both of you, for coming and presenting this evening. I've really enjoyed it, and I hope that you have also had a chance to think about some of the things that they brought up and ask some questions. Again, we will be back in a month's time, the first Wednesday of each month. And that is it from us, from Cloud Native London, for tonight's meetup. So again, I will not see you for the next couple of months, but I will be back very shortly. Thank you so much. Have a good evening.
Thank you.
Thanks.